Solar Flare Visits Earth by H. Sad and K. Sad. Hi, I'm Flare, and I'm super excited to be visiting your amazing planet Earth. I'm so happy you're coming along on this fantastic adventure. Let me tell you a bit about myself and my family. That's my mom behind me. She's the closest star to Earth, only 93 million miles away from you, and her name is the Sun. Look up and you'll see her in your skies. She gives you light and heat. Mom loves to spin around. She's been doing it for billions of years. And it's not the usual kind of spin either. Her middle equator spins faster than the top and bottom. She's so much fun. Every 11 years, she spins on her head and stays like that for another 11 years before flipping back up for the next 11. We call it her magnetic flip. Whee! She has lots of magnetic fields, like strands of invisible hair. When she spins, and well, she always spins, they get all tangled up. Tangly fields give Mom sunspots, and she gets stormy. She shoots out energy and particles, which are little pieces of stuff, and those make solar storms. That's how my siblings and I were born. Solar is just a fancy way of saying something to do with my mom, the sun. Solar storms can make solar flares like me. I'm super fast. I zoom at the speed of light. I'm a huge flash of light and energy. I could zip around Earth 7 times in 1 second. Solar storms can also make radiation storms, like my big brother Rad. He tries to keep up with me. He's made of fast particles. He loves to surf along magnetic fields in space. Mom makes them with other planets, and they loop and curve like invisible roller coaster tracks. Not as fast as me, though. It takes Rad about half an hour to a few hours to reach Earth. He says he's taking a more fun path, but I think he's just jealous that I beat him. Solar storms can make solar wind like my little sister Bubs. She blasts out from Mom like sparks from a fire. She isn't air, she's hot sun gas, forever flowing in every direction and surfing magnetic fields. Finally, solar storms can make CMEs like my brother Bubbles. CME means coronal mass ejection, but I call him Cloudy Mega Elephant because he stomps through space like a giant blobby bubble. He's so huge you could line up thousands of Earths inside him. Bubbles is a giant cloud of hot gas and magnetic energy. I teased him that Mom burped him out. He didn't like that. He tried to chase me, but he's too slow. It takes him 1 to 3 days to reach Earth. I'm lightning fast, just 8 minutes to Earth. Solar flares like me are born when Mom's magnetic fields twist, snap, and reconnect near her sunspots. It's like Mom sneezes me out. Bubbles doesn't like me saying that, but it's exactly what it feels like. Ha! Our family is so famous, the satellite space paparazzi are always watching us. I think NASA is obsessed with us, and Mom's the biggest star of all. Look! An astronaut! He has to run inside. It's not safe when we come by. I give off dangerous radiation, and Rad blasts speedy particles. They can zip right through spacesuits and cause radiation sickness, which makes astronauts feel sick, tired, and weak. That's why the International Space Station has safe places with extra shielding. No spacewalks when we're around. Bubs is already here because Mom never stops creating Bubs. It can take her anywhere from 2 to 4 days to get from Mom to Earth, but because Bubs are constantly being made by Mom and always blowing here, she's always around. She loves to play with Earth. When Bubs blows against Earth, most of her wind gets pushed away by Earth's magnetic shield, magnetosphere, and slides off into space, like air rushing around a rock. But near the North and South poles, the magnetic field lines curve down toward Earth's surface. There, the magnetic shield is weaker and open, like 2 little doorways. Some of Bubs's charged particles sneak through these polar openings and travel down the magnetic field lines like invisible roller coaster tracks. When Bubs gets a little too excited, she fills Earth's magnetic loops with her energy. Those loops turn into giant glowing donuts called radiation belts, like invisible hula hoops spinning around Earth. There are 2 belts, the inner one's full of slow, chunky protons, and the outer one's full of speedy, zappy electrons that race around super fast. When Bubs blows gently, the belts stay calm, but when she really lets loose, whoosh, the outer belt swells and buzzes with energy. Satellites flying through the belts can get hit by radiation. Tiny electric charges build up and can confuse or damage their circuits. That's why operators on Earth put satellites into safe mode during strong storms, so they don't get hurt. Sometimes missions are delayed and astronauts stay inside protected areas until it all settles down again. Other cheeky bubs sneak through Earth's shield and slide down the magnetic fields to the North and South poles. High up in the air, in a layer called their thermosphere, far above the air you breathe, they bump into gases. When they hit oxygen, the sky glows green or red. When they hit nitrogen, it glows blue or purple. That's how my little sister Bubs paints auroras. Her glowing light shows near the North and South poles. Bubs paints the skies with magical green, purple, and red lights that shimmer and dance. These glowing shows appear near the top of Earth, at the North Pole, and near the bottom, at the South Pole. Earth's skies sparkle with dancing lights whenever Bubs comes to play. Pretty, but also proof her particles are sneaking past Earth's defenses. You know how Mom's magnetic hair gets all twisty and tangled until she suddenly snaps and sends me flying out? Well, Earth can do the same thing. When Bubs blows past, she stretches Earth's magnetic field into a long tail behind it. The lines get pulled so tight they eventually snap and reconnect, just like Mom's do. When that happens, Bubs' leftover particles get flung back toward Earth's poles, lighting up the night side with dancing auroras. It's like a tiny version of Mom's sneeze, but this time, it's Earth's turn to shine. Bubs loves to heat up the upper atmosphere, the thermosphere. When she gets all excited, she puffs it up like a balloon. Satellites flying through bump into more air and start to slow down. That makes them sink lower, so they have to burn extra fuel to climb back up. If they run out, oops, they can't stay in orbit and might fall back to Earth. And when they sink lower, they wear out faster, no matter how much fuel operators use to push them back up. Typical Bubs, always stirring things up. She manages to cause mischief with satellites both high above Earth in the radiation belts and lower down when she warms the skies. And from what I've seen, you humans really need your satellites. GPS even tells tractors where to go, so they plant in perfect straight lines. That way, no space is wasted, more food grows, and farmers save seeds, fuel, and time. It even works in the dark or fog. But when Bubs gets all wobbly and shakes up GPS, those poor tractors can end up zigzagging across the fields instead of straight. That means less food and a lot more hard work for the farmers. Astronauts depend on satellites too. They use them to talk to Earth and to get warnings when Rad or I blast out storms. Without satellites, they could lose contact and wouldn't know when it's time to hide in safe spots. Airplanes rely on satellites to guide them safely through the sky and to keep pilots in touch with the ground. But when solar storms upset satellites, radios can suddenly go quiet and flights may have to change course, leading to delays, or sometimes safety risks. Power grid operators watch satellites carefully for storm warnings. Without them, Bubs and Bubbles could strike before anyone noticed, and whole cities could go dark in a blackout. I'll tell you more about that later. Emergency managers need satellites too. They rely on them to warn people when big storms or disasters are coming. Without satellites, warnings would be slow, or might not come at all, and people wouldn't be ready to stay safe. Humans really can't live without satellites. And without them, oh boy, life would be a mess. Phone calls could drop, TV screens might go blank, and the internet could suddenly vanish. Deliveries and shipping would slow down, and online shopping packages might never show up. Weather forecasts would be weaker, and dangerous storms could strike without warning. Power grids wouldn't know when we were coming, and whole cities could go dark in giant blackouts. See, Bubs, when you blow too hard, humans can lose their lights, their signals, and their safety. We need them too? Or who will take our pictures and watch us?
Rad, I'm measuring your particles right now. How strong are you feeling?
Smile, son. Can I get a close-up of those sunspots?
Hey, Bubs. How's the breeze today? Fast or slow?
Pose for me. I need to catch your storms from every angle for my 3D shots.
Bubbles, you're loud. You're shaking my instruments. Any comments?
Oops! I was going so fast that when I hit Earth's magnetic shield, I ended up shaking the ionosphere, and now it's all wobbly. The ionosphere's like Earth's electric blanket. It starts near the top of the mesosphere and stretches up through the thermosphere into the lower exosphere. Sunlight keeps it charged with energy, which makes it perfect for carrying radio and GPS signals around the planet. But when I pass by, all that charged gas starts to ripple. GPS and radio beams bend, scatter, and sometimes drop out completely. Satellites in safe mode escape the worst of it, but if I reach them first, my burst can still overload their circuits and cause glitches or reboots. It would be easier if they were tucked safely inside Earth's atmosphere, but then they couldn't do their jobs. My blasts only take 8 minutes, so by the time you see me, it's already too late to stop me. Oh, look at that! You humans are clever. I can see your planes changing their flight paths to places where radios and satellites still work. And that tiny GPS hiccup? Farmers don't seem too worried. They've stopped for now or just switched to planting the old-fashioned way. Huh, you always find a way to keep going, even when I stir things up. It'll settle down soon, I'm sure. Sorry. And I was just saying Bubs was causing all this chaos. Rad's fast, but he's heavier than me. He's made of charged particles, not light. Most of him gets pushed aside by Earth's magnetic shield. Next, some of Rad's particles follow the magnetic field lines down at the north and south poles, where Earth's magnetic shield is weaker. His particles funnel in and shake up the radio waves that planes use to talk to the ground. But this time, the humans were ready. They'd already rerouted polar flights after my flare hit, just in case Rad showed up behind me. Pilots switched to safer paths farther from the poles, even though it meant longer routes and more fuel. Rad doesn't mean to cause delays or make them burn extra fuel. He just gets pulled along those magnetic tracks and can't stop himself. Here comes my big brother Rad, racing in with his speedy particles. The astronauts always meet him first. His particles are so fast they can zip right through spacesuits and even spacecraft walls. That's why they're already tucked away in the safe parts of the space station after my blast. But even in hiding, some of his particles sneak in. Rad's particles are strongest outside Earth's magnetic shield. That's why astronauts in space, satellites in high orbit, and spacecraft on the way to the moon or Mars are most at risk. Inside the magnetic shield, in low Earth orbit like the ISS, astronauts are still partly protected. They can get small doses of radiation, but not the full blast. It's not enough to make them sick right away. But tiny doses of radiation add up over time, and Rad worries about that. He doesn't mean to hurt them. He just can't help spilling particles everywhere when he races by. Next, Rad storms toward the satellites. His charged particles hit them like static electricity. When enough builds up, it sparks, and that can fry delicate circuits inside. That's when satellites glitch, reboot, or sometimes even fail. Operators had already put them into safe mode after my blast, so they're safe from the worst, but Rad's hits still wear them down. Each time he passes, their systems age a little faster, and even small bursts can make sensors misread data or power flicker. Remember the belts that Bubs made? And when Rad's feeling extra stormy, he pours into Earth's magnetic belts. The Van Allen belts, those invisible donut-shaped zones full of trapped particles. He stuffs them so full, they become stormy, and satellites flying through those belts can get hit hard, their electronics scrambled or their shielding worn down faster. GPS signals passing through the belts can wobble too, drifting and leaving people on Earth with less accurate directions. This effect can last for days. Rad always says he's the stormiest of us, but the truth is he doesn't want to cause trouble. He loves surfing those magnetic roller coasters and sometimes forgets how powerful he is. He cares about Earth and the people watching us. He just wishes his fun didn't make so much extra work for everyone. And just when Earth starts to breathe again, here comes my little brother Bubbles. He's always the slow one, taking a whole day or more to stomp his way to Earth. By the time he shows up, most of my flare chaos has faded, and Rad's radiation storm has started to calm down, but don't relax. When Bubbles arrives, he's huge, heavy, and impossible to ignore. Bubbles is so big that when he slams into Earth's magnetic shield, he bends it and pushes it back. That's when the skies explode into auroras that spread far beyond the poles, glowing in places that don't normally see them. They're beautiful, but they're also proof that Bubbles' energy is spilling deep into Earth's system. When Bubbles' magnetic field reaches Earth, it's like two magnets meeting the wrong way. They push and twist until, snap, energy rushes into Earth's magnetic shield. You know how Mom's magnetic hair gets all tangled until she suddenly snaps and sends me flying out? Well, Earth can do that too. When Bubs blows past, she stretches Earth's magnetic field into a long tail behind it. Those magnetic lines get pulled so tight that they finally snap and join back together, just like Mom's do, and make auroras at night, remember? When Bubbles arrives, it happens on a much bigger scale. His magnetic field locks onto Earth's and shakes it from one end to the other. If Bubbles' field points south, It connects with Earth's north field and really stirs things up. That's what starts what you call a geomagnetic storm. The magnetosphere starts to vibrate and twist as it absorbs the energy from bubbles. This energy travels along magnetic field lines down toward the polar regions, where the magnetic field is open. As it moves, charged particles rush into the ionosphere, the upper atmosphere, making it glow with auroras and become electrically active. When all that magnetic energy hits the ionosphere, it sets up electric currents That's high when above power Earth, grids feel his heavy hundreds steps. of kilometers
His
up.
magnetic
storm drives extra electrical currents through the ground, flowing into wires and transformers. Whole cities could suddenly go dark. Bubbles doesn't mean to. It's just that when he stomps, the ground shakes and the wires can't handle it. Satellites get knocked around too. GPS becomes shaky, compasses start to wiggle, and radio signals cut in and out. Planes and ships relying on navigation notice right away. But Bubbles doesn't realize he's pushing them. He just keeps floating along, unaware of the chaos behind him. Humans, though, are smart. They see him coming days ahead, using their satellites to spot him leaving Mom. Power companies shift loads and protect their transformers. Satellite operators delay important jobs and tuck instruments into safe mode. Pilots and captains get warnings so they know GPS and radios might go fuzzy. Emergency managers even warn whole regions to be ready just in case the lights flicker. Bubbles always says he's the biggest of us, and he's right. But he doesn't mean to cause problems. He's like a clumsy little brother who doesn't know his own size. When he stomps, Earth shakes, the lights flicker, and the skies glow. But he's not trying to be scary. He just doesn't notice how strong he really is. But hey, Mom says there was a time when you humans didn't even have technology at all. You could live without it again, right? Back to caveman days with fire and stone tools. What's that? You don't want to? Ha ha ha. Okay, fine. Maybe one of you will grow up to invent something that protects Earth from us for good. Who knows? It might really happen one day. That way we can come and play without causing chaos. And don't worry, Mom calms down after her solar storms. When she's calm, we call her mood solar minimum, because Mom looks mini when she's calm, ha ha ha. When she's the most stormy, right before she does her flip, we call her solar maximum, because she's stormy to the max. Mom calms down because her little sneezes of energy tend to get rid of her sunspots and tangles. She still keeps spinning though, so they always come back. So I'm sure you'll get a visit soon from more of my brothers and sisters. Tell them I said hi when they come to visit, even if they do accidentally play a little too rough. Ha ha! Thanks for watching. See you next solar cycle.